No. I'm just going to start off right here. So we got to come up with the least and we got to come up with the greatest. What operation do I do to a number and I make that number small really quick? Taylor, division. When I divide a number, it takes a big value and makes it small really quick. What's another operation that does that? Yeah? Subtraction. So those are two operations where I know if I do division or subtraction, it's going to make the number smaller. If my number is big and I'm dividing, it makes it small by a lot, really quick. If my number is big and I subtract, not so much unless I'm subtracting a lot, right? So let's think of the flip side. If I have a number and I want to make it bigger, what do I do? James. I multiply. So if I do a bunch of stuff and then the last thing I do is multiply, what happens to that number? Boom. It gets big. If I do a bunch of stuff and then the last thing I do is divide, what happens to a number? Shoot. Okay. Now that I've said that, that should help you figure out where to put the brackets, the parentheses for this expression. Go. Talk to your partner and work with your partner. Hold that thought. Work with David.
To make the smallest, I think it's around 21 negative.
Now remember, what's the last thing? Are you trying to make it bigger or smaller? Bigger. So the last thing I want to do, okay, so if the last thing I want to do is make it smaller, what should be the last thing that if I want to make it smaller, what should be the last thing I do? So think about where to put those parentheses.
Because if it is 3 plus 21, it would make it even greater times.
Orlando, what do you think? You got him? All right. You had it earlier, right? Okay. So, I was looking at Kendra's work earlier, and her and Orlando have been working together. So, if I'm going to make a number small, what should be the last thing I do? Divide. So I'm going to put my parentheses here and there. So now, yeah, I can do that. So now I got to figure it out. So I have to do the work in the parentheses. So Anthony, knowing the order of operations, these, right, PEMDAS. I look inside my parentheses. What should I do first? Should I do the addition or the multiplication? Multiplication. So I'm going to go 25 times 3. I'm just going to round, right? So it's 75. 75 plus 21 is 96. 96 divided by 3, roughly 32. Right? I know I got that 0.2 in there, but we're not worrying about that. We're estimating because we're just trying to make the least and the greatest. Is that a lot smaller than 82? Yeah. That is. So now I divide if I want to make something small as the last operation. What would I do to make it bigger? I divide first and then do what last? Multiply. So this becomes that. See that, Jackie? So now, what do I have to do inside? I got to do the division first. So I get 7. 7 plus 3 is roughly 10. 10 times 25? 250. Bam, huh, Riley? So Guys, this is a great problem. You're practicing your PEMDAS, but you're also thinking about what the operations do to your sums, what they do to a product. It's really fun practice. All right. Make sure you, I probably didn't give you guys a lot of work today, time, but I'm going to give you time at the end of class on this. Tomorrow, I'm here at 7. So anyone who wants to retake the partner test, I'll release the grades. You should have seen the grades. They're in your email. If you don't know what you got, look at them before you go home. If you don't have internet at home, do it here. 7 a.m. You can come, retake the partner quiz, the quiz you took the other day, investigation 2 retake. If you are going to do the investigation 2 retake, you need to make sure that you have this. I don't think anyone in here really needs to, but just as an option. You got to do that first. I can statement. Okay. Raise your hands if you know what distributive property is. That's what I thought. Not many. Maybe a little bit, right? Okay. Raise your hand if you've heard of a partial product. Okay. The reason why is that's everyday math, right? Everyday math calls them partial products. That is distributive property. That's like the basis of distributive property is this idea of a partial product. So it's some of that. Now, what does it mean to distribute something? Yeah.
You said you have like 5 apples and there's 5 people you just
All right. So if I gave Lulu a bunch of candy and she went around and she gave James 15 candies and everyone else 1, is that distributing? Kind of, but not evenly, right? This distributive property means you need to distribute evenly. Whatever you distribute, it gets distributed evenly. So, expand. What does expand mean? Talk to your partner about expand. 10 seconds. Okay. So, I want you to think, there's 2 things that I think of when I think of expand. One's a balloon, right? A balloon expands. It changes in size, but no. It changes in size, but it's still a balloon. It's still what you started with, but it looks different. It's bigger. The other thing, which is really, I loved these as a kid. They're those little tiny, they come in like little pills, and they're like the foam things, and you put them in water, and then you leave them like a week, and you totally forget about them, you come back, and they're like huge. You can buy ones that come in like pills like this big, and they get to be like that big. And all they do is like, they soak up water, and what do? They expand. They get bigger, but it's still the same thing. It might look a little bit different. Okay, you can see more details, right? But it's just expanded, it's just bigger. Factor. So, what's a factor of 6? Jackie, do you know what a factor is of 6?
It'd be 2.
Nice. 2 and 3 and 1 and 6. Okay, so factors are numbers that go into a number, right? So what would be a common factor between these 2? 2 and 1. So factors are numbers that go into another number. So let's say we got distributive property, which we talked about is kind of like partial product. Okay? Similar. It's kind of like the foundation of it. We have expanding, which means it gets bigger. We have factor, which means it's kind of like you're trying to figure out numbers that go into other numbers. And we're going to do that with integers. So that's kind of what we're going to do today. It's a lot of new learning. And it's some that we're going to watch a math antics video, Rob. Okay, because he does like a great job. Plus he's a little quirky and kind of funny. He's way funnier than I am. Okay. I want you to go to page 86. 86, homework. Whoops, wrong one. Here we go. All right. Here's 86. All right. Problem 4. I want you to check your homework on this, so make sure you have your homework out. And I will check your homework while you're working today. But get your homework out. Page 86. Because every class has kind of been all over the board on these. Which is great, because I've had incredible turnout. One kid didn't do their homework so far. So here I am. I'm talking to the class that I talked to yesterday. We're going to see how you guys do. And that's in 3 classes. And I'll tell you, you learn a ton. And it's not that they did it right, but as soon as you look and you're like, oh, the chance of you making that mistake again is that much smaller. What's the first thing I should do in this problem? Warren. Okay. Are the parentheses showing an operation or a number? These are a number, so I don't have to do that first. Then what? Do I have exponents?
No.
Nope.
You multiply the farthest to the left.
So whether it's division or multiplication, furthest to left. So here I have 4 times 2. And you can check this as number 4. So 4 times 2 is 8. And I'm going to rewrite it again. Take it one step at a time. So now what? Michaela, what do I do now? 8 times 3. And negative 3. So I get a negative 24 plus negative 10. Divide by 5. David, then what?
Then you would add, or no, you would divide negative 10 and 5.
Good. Remember, I cannot, this is really important because I noticed this yesterday. I can't go here until all of that is done. Once I do all my multiplication and division, then I can do addition and subtraction. So I get negative 2, negative 24, yep, thank you, equals negative 26. So check your work. That should be negative 26 on that answer. Because a negative plus a negative is like...
Adding up.
No, adding a negative is like subtracting a positive. Okay. Go to your number 7, way harder. I want you guys work with your partner, check your work. Go.
Boy, I got 34. So you do these on
We're moving on. Just make sure we get it done today.
Sorry. So it's 10 minus 1 minus 17. So 7 minus 1 is equal to 10.
All right, here we go. Tough problem. Lot to do. We have parentheses. We have brackets. We have exponents. We got multiplication. We got division. We got subtraction and addition in the end. So we have a lot. I mean, you have every operation in this problem. Parentheses inside brackets. You do these first. Negative 25 negative 2 times 25, negative 50. So So then the next step, I go left to right. Negative 50 divided by, 50 divided by negative 50, negative 1. Then, negative 1 minus 7, negative 8. A lot of kids made mistakes here. They went the wrong way. A lot of kids got 6.
I got negative 6 though. Wait,
yeah. So you must have thought that was a 1 or something.
Oh yeah, I thought that was a positive.
Yep. So then, negative 8 times 4. And I got 4 because 2 to the second power, that's 2 times 2. That equals 4. Negative 8 times 4 is negative 32. And then I told you there is addition in the end because you have 10 minus negative 32. Subtracting a negative is like adding a positive. Answer is 42. If you got that, you can pat yourself on the back because that is a hard problem. So, take it one step at a time. So today we are going to watch Rob. You need to have your notes in front of you for today. You should have been writing those down today. Wednesday, did you? Nice. Okay. Save that, okay? Here are your notes. All right. Go to your notes. You will be taking these notes during the lesson. Yeah, that way you participate during the video.
Like you're listening and then
In this video, we're going to talk about a really important math concept called distributive property. Well, at least that's what it's called. You may hear it referred to as the distributive law, or even the distributive property of multiplication over addition, by people who want to sound really technical. But no matter what it's called, the concept of the distributive property is the same. Before we actually dive into that concept, there are 2 quick things that will help make it easier to understand. The first is simply knowing what the word distribute means. To distribute something means to give it to each member of a group, like an old-fashioned paperboy delivering newspapers to each house in a neighborhood. One for you. One for you. Sorry. One for you. And one for you. The second thing you need to know is the order of operations rules of arithmetic, which we cover in another video. So you might want to watch that if you're not familiar with those rules already. That's because the distributive property is actually a way of allowing us to change the order of operations we do in certain types of problems. To see what I mean, have a look at this simple arithmetic expression, 3 times the group 4 plus 6.
Okay, go ahead. That's the first box. Okay, and solve it using order of operations. Just going to give you like 10 seconds to start. Yeah, it should be.
We're going to simplify this expression in 2 different ways. The first way, we just use the basic order of operations rules that you already know. But the second way, we use the distributive property. And if we do the arithmetic right, both ways will give us the same answer. So for the first way, our order of operations rules tell us that we need to do any operations inside of groups first. And since these parentheses form a group, we first need to add the 4 and 6, which gives us 10. Next, we can multiply that by 3, which gives us a final answer of 30. Now, let's use the distributive property. The distributive property allows us to change this expression into a different form.
The form is called expanded form. So, if we're going to change this to a different form, an expanded form, what's going to happen to it?
It's probably going to be a bigger problem.
It's going to be bigger.
Instead of multiplying 3 by the whole group at once, we can distribute that factor of 3 and multiply it by each member of the group individually. That means we'll make a copy of the 3 times for each member of the group, the 4 and the 6. So after applying the distributive property, our expression looks like this: 3 times 4 plus 3 times 6. Because we distributed the multiplication to each member of the group isn't needed anymore, so the parentheses can go away. Now, we can continue to simplify this new form using our order of operations rules. Those rules tell us to do multiplication before addition.
Okay. Write down the expanded form in that second box, and then solve it using the order of operations.
3 times 4 is 12, and 3 times 6 is 18. The last step is to add those two results together. 12 plus 18 equals 30. Well, look at that. We got the same answer in both cases, which means our original expressions are equivalent, even though they have different forms. In the first form, the factor 3 is being multiplied by the entire group all at once. So we needed to do the addition inside that group first. But in the second form, we use the distributive property to rearrange the expression so that the factor of 3 is multiplied by each member of the group individually instead of the whole group all.
Okay, so above this box that has this is called factored form. I want you to write that. That's factored form.
Wait, where do we write that?
You write it above. So that's called factored form because 3 is the factor that they pulled out. Because 3 goes into 12 and 3 goes into 18. That's basically what they did over here. Is they pulled that out and then they're left with 3 times 4 plus 6, which is this. Okay? This is called expanded form. So above that box, write expanded form. Those are two terms you'll see. Factored form, expanded form. Factored form is a little bit smaller, has a common factor. Expanded form is bigger, okay, because it's taking that factor and distributing it all at once.
Distributing that factor made the group go away, so we didn't have to do the addition inside that group first. So the distributive property is basically a way of getting rid of a group that is being multiplied by a factor. If you distribute the factor to each member of the group, you'll get the same answer you would if you calculate what's in the group first and then multiply. And it works no matter how many members are in the group. Like in this problem, you have to multiply 4 by the group 1 plus 2 plus 3.
Okay, go for it. Solve it both ways. Solve it first way, okay, in the factored form order of operations, which is the easier way right now. Then solve it with the expanded form way, the distributive property way, the second way.
Again, let's try simplifying this both ways. In the first way, we start by simplifying what's in the group. 1 plus 2 plus 3 equals 6. And then we multiply 4 times 6, which gives us 24. Now, let's use the distributive property. We distribute a factor of 4 to each member of the group, which makes the group go away and allows us to do those multiplications individually. 4 times 1 is 4. 4 times 2 is 8. And 4 times 3 is 12. Finally, we add up those 3 individual answers. 4 plus 8 is 12, and 12 plus 12 is 24. See, the distributive property gave us another way to arrive at the same answer. It's like the distributive property is an alternate path that you can take to arrive at the same point. Well, what are you doing here? I'm always here. Okay, great. We have 2 ways to get to the same answer. But why do we need 2 different ways to do the same calculation? And it seemed like the distributive property way was even more complicated than the regular way.
So, Anthony, that was a great question, right? Why would I make this more complicated?
Why would we ever want to use it? That's a good question. And it's true. There are times when the distributive property way is harder, like in our first problem. It was easier to just go ahead and simplify the group first because it's easy to multiply 3 times 10 mentally. But there are also times when the distributive property way is easier. Like in this case, 8 times the group 50 plus 3. If we decide to simplify the group first in this problem, we end up needing to multiply 8 times 53, which is not so easy to do mentally. But if we apply the distributive property instead, we can change the expression into 8 times 50 plus 8 times 3. And that's easier to do mentally. 8 times 50 is 400, and 8 times 3 is 24. So the answer is 424. Realizing that the distributive property can make some calculations easier to do mentally can come in really handy for certain basic multi-digit multiplication problems. That's because you can break up the multi-digit factor into a group sum, like expanded form.
And you guys called it, this is partial product. right? Where you take a sum, you break it up into the hundreds, the tens, and the ones. You call this partial products. But that literally is distributive property.
And then distribute the other factor to the members of that group. Sound confusing? Here's what I mean. Let's say you need to multiply 5 times 47. Well, you can just...
Okay, that's your, that last box on there. Choose which way to solve it. You can solve it in the order operations way, or solve it in this distributive property way, where you're doing a partial product of 47. So partial product of 47 be broken into 40 and 7.
Just use the multi-digit multiplication procedure, or you could change this into a problem where the distributive property will make it a little easier to do. The key is to realize that you can replace the 47 with 40 plus 7. Then the problem becomes 5 times the group, 40 plus 7. And the distributive property lets us change that into 5 times 40 plus 5 times 7. Those two multiplications are easy to do. 5 times 40 is 200, and 5 times 7 is 35. So our answer is 200 plus 35, or 235. Want to see another example? Let's apply that same idea to this multiplication problem. 3 times 127.
Okay, there's a spot, open spot, right next to the box that you just were doing, and you can do it either way. Last practice. Give you like a 15-second head start, and I'll start the video.
Wait, can we solve it in the distributive property?
You can, or you can just do it the order operations way, which that would be just multiplication.
But instead of 127, let's change that into the group 100 plus 20 plus 7. We need to multiply that by 3, and the distributive property lets us distribute that multiplication to each member of the group. 3 times 100 plus 3 times 20 plus 3 times 7. That helps because we can do those mentally. 3 times 100 is 300. 3 times 20 is 60. And 3 times 7 is 21. All that's left to do is add those 3 products up, which is not too hard to do mentally either. 300 plus 60 plus 21 gives us 381 as our final answer. Now, before we wrap up, there's one more important thing that you should know about the distributive property. You already know that the distributive property works when the members of a group are being added. But it works the same way for members of a group that are being subtracted.
Why is that, you think? Why is it that the distributive property works with addition and subtraction? What is subtraction? Another way to think about it. David?
The opposite of addition.
The opposite of addition. So when I subtract, what else could I be doing?
Divide.
Adding a negative. That's why it works. Because it literally is adding negatives.
Like in this problem, 7 times the group 10 minus 4. You could...
Okay, I'm going to pause it there for a second. So, distributive property works when inside the parentheses you're adding or subtracting. It does not work with multiplication.
Yeah.
So, for instance, this problem... I will. Yeah, 1 second. This problem here. If I do it order of operations, would tell me do this first, right? That's 6. 6 times 3, 18. Let's say I do distributive property way. 3 times 3. Okay.
3 times 6.
And that would be 3 times 2. So I get 9 plus 6. That equals... not equal. So it does not work when you have multiplication or division. Okay? So anytime you have multiplication and division inside a parenthesis, it doesn't work. But I can do the multiplication as an order of operation, get rid of it, so then all I'm doing is adding and subtracting. Then I can do the distributive property when I get to this stage here. today.
Are we supposed to do the U-try problem?
Yeah, that's what I'm going to give you time right now to do. So go ahead, do the you try. It's not super difficult, but it's good practice.
I think I want to do it. You didn't tell us to do like the X and the Y and stuff.
Uh-huh.
Are we doing that?
You can look, no, we're doing this one over here. See what I did here? Here, I have a 6, a 12, and an 18, right?
But what are these?
X and Y.
I know, but what are
We don't know what they are yet. So what I said was, hey, 6 goes into 6, 6 goes into 12, 6 goes into 18. So I pulled out the 6. Put the 6 on the outside, and I say 6 times 1.
Where are you getting 1 from?
Well, 6 times 1 is that 6 right there.
Okay.
And then 6 times 2x would give me 12x. And then 6 times negative 3y.
Why do you have a parenthesis inside your parentheses?
Just showing you that's a negative 3. That's all. All right. So today.
No, but plus negative 3 doesn't make it 18.
Let me come back to you. I'll come back to you. Today, problem 4.2. Like I said, I'm going to give you time to work on problem 52. But first, we have A1, B1, B3, B5. A lot of you will get down through the C's. Now, when you get here, this is going from factored form to expanded form. C is going from expanded form back to factored form. Okay? So just be clear on that. Go ahead, read number A1. How you doing on this one? I want you to understand this more than that over there. Yep, you simplified it. Now do it the expanded form. So go 3 times...
Negative 3.
Yep. Plus 3 times... Yep, negative 3 times 7. Bam! Bang. It's great, Max. Ooh, battery's low. Can the Swivl hang on? I don't know.
Probably not. No. I'm not helping that.
Okay, get going, guys.
Put on the back of this?
Yep. How much money does Juan have? He's got $100. He has $100. How much money does Juan take out? Wait, how much money does he take out first? $19. How much money does he take out second? $30. So that's one answer. What's the other way?
Minus 40.
It's 100 minus 19 plus. So I add up his debt, and then what do? Subtract it from 100. So those are the two ways that you could write that. I could add up the debt, then subtract it, or I could take his total, subtract, and then subtract again. You guys work with your partners on B1, B3, and B5, okay? I want some dialogue here. Oh yeah, please have on your desk homework from last night.
Okay, so we're gonna do 3 plus 2. Like that.
One minute, it's in the grade book.
Thank you.
Uh-huh. 4, 5, 6, 7, right?
And then we do 5 times 5. Just put it back.
Yeah, you got that one, right?
Okay, now I'm on.
Good night, now, good night. Did that help today?
Yeah.
Okay, good.
I get confused on the exponent.
5.
Jake, you can do it, Jacob?
That's 25.
Nice work. Common mistake, like I was saying, right? Adding.
Times 3.
Good, did this help you today? You got that one right.
Oh, we're skipping that one? We're going to go back there. Okay.
Yeah, you did a lot of adding wrong.
B.
And in this one, you didn't follow the order of operations.
5.
Okay.
But good, Jacob, keep working.
Make sure you put parentheses.
Thomas. Bam, bam. Not far.
Yeah.
Definitely, right? But we went on top. So
Now.
nice. We'll get off of
5
that.
times 3 plus 2.
Okay, so we know you need to do B5.
No big deal.
5 times 3 plus 5.
Wait, are we even doing something?
Third one. 5 times. Then we just have to do all of them. I find that out.
Wait, is B5 just telling us to do everything again?
You're going to get intelligence for it.
No, it's one thing to like turn it into.
Do any push it
Like, just the answer for it. Is B5 just like?
Yes. That's right.
Yeah, B5's not really clear. It's like
I always just work at
telling us to do what we
I have
just
no
did.
idea what you're talking about.
Oh yeah.
And then I also like
Not 6.
Stay common. A negative plus a negative keeps going.
yeah. Oh, and then I have
Yeah, you gotta work with that.
Oh, I see. This here. I meant to write that in expanded form and not and then use the answer. Yeah. I mean, we only did B1 and B3.
I'm just saying.
Only.
Oh, it would just be
Just saying.
5 plus 3 or times 3.
Is B5 telling us to do what we did?
Holy chicken scratches. Chicken's right there.
Oh my god.
So after this, so we
No,
already.
no. I didn't say you had the right perfect. You should have better than that. Not right.
Okay.
Right back.
Okay. So here's.
Say what? B5?
I know. I figured it out.
Solve 1 and 3.
We already did it, but what we were actually meant to do there originally was do the expanded form. So just keep the answer.
Yes, you want to do it expanded form.
So keep the answer and just put slashes here and do both on the same line. So this one would be 5 times 3 plus 5 times
You solve B1 and B3.
We already solved.
Perfect. So you're done.
Oh, wait. That'd be interesting.
Hey.
5 times 3 plus 2. Okay, and the next one is.
Good. Okay.
No, we didn't need to work. 5 times 3 times 3 minus 5 times 2.
What was that? Oh, this is already written. It's probably
Okay, C1. Okay, C1. Okay. Okay, no. So,
did good. You did really good work.
So it would be 6 times 2 times 3.
Yeah, but you just added wrong, went the wrong way like you did yesterday. And then it messes up everything. Did you have what you want?
6 times 2 plus minus
No, 6 times 2.
6 times
Plus 6.
Yeah, that's it. So now you need to write this in factor form.
X times
Yes. Yeah, you need to do opposite, right? So you wanted to expand it first. Now that they're giving you expanded, you need to go down a factor.
6 times 2.
Wow, this class is stepping it up.
plus 3.
Wait, so 6 like this?
Oh my god.
Thank you.
Oh, you have to do all meters.
6 times 2.
Oh, minus 3. Wait, 6 times 3.
What? No, it's 6 times 2 plus 6 times 3.
No way you did wrong. Or is that 42?
So, oh, I get it. No, it's just.
Yeah, that looks like
No.
7.
No. Look. You could have just
Yeah,
put this. Look. 6 times in parentheses. 23. Because it's coming, use distributive property to write each expression in factor form. So remember, it would be 6 times 2, because let's say you had 10, you'd split it up, and let's say you had 5 and 10. You would have, 5 times 1 plus 5 times 0. So in these, and the reason 6's are here is because this is the distributive property, so 2 plus 3. So that's why it's saying 6 times 2 plus 6 times 3. Yeah, no, you can even do the math.
You
Look.
can do either one. So
Yeah, it's 6 times in parentheses, 23.
or you can do it.
You multiply the 6, and that's why it's 2 6s. Take this 8.
Yeah. Now, ready? Just take up the 3 now. Or just put 3 and see if you see it. All right, guys.
6 plus 2 plus 3.
Let's put this away. You guys are rocking this. This is awesome. Put this away. Put your learning back.